Fuses and cutouts. System reliability and equipment protection are important considerations for an electric utility. Fuses are an important component used to protect the electric system and the equipment that is connected to it. Examples of these are transformers, capacitors, and other expensive hardware. Fuses also aid in sectionalizing the independent circuits of the electric system in case of equipment failure. Fuses used in the electric distribution system typically have three components. They are the fuse head, which has information about the capacity and type of fuse stamped on it. The fuse element, which is connected to the fuse head. It is constructed from a lead alloy that will melt at a predetermined temperature. When this happens, the electrical circuit is opened. The fuse element is a mechanically weak component. It has a fiber cover which provides rigidity and strength. This cover also helps extinguish an arc when the fuse blows. The tail is the final portion of the fuse. It is connected to the fuse element and facilitates mounting in the fuse holder. Cutouts. Distribution system cutouts are designed as high-tension mounts for fuses. The most commonly used cutouts are the box type. In this type of cutout, the barrel and contact points are enclosed in a porcelain box. This type of cutout is normally designed to be used with voltages of 7.2 kV or less. The open-style cutout, which is the most commonly used cutout in distribution systems. This type of cutout contains upper and lower points of contact and a barrel, which are exposed to the elements. When the barrel is in its open position, the circuit is broken and electricity does not flow. When the barrel is closed, the fuse is the element that completes the circuit and allows electricity to flow. A cutout of this type can be mounted on a steel crossarm with a single bolt. It can also be mounted on a wooden crossarm with the metal bracket, which is normally included with the cutout. The cutout should be installed with a slight angle toward the pole. This allows easier operation of the cutout from the pole. An improperly installed cutout will make future operations more difficult. The barrel. One end of the cutout barrel consists of a contact cap and an eye for opening and closing with a hot stick. A vulcanized rubber tube covered with fiberglass joins this with the other end, which contains hinged contact points, a fuse tensioner, a nut to secure the tail of the fuse to the bottom terminal, and another eye for installing the barrel in the cutout. The tools needed to install the fuse in the barrel are usually determined by the manufacturer. Generally, to install a fuse, only pliers and a crescent wrench are needed. To install the fuse, remove the cap of the barrel and loosen the bottom nut. Thread the tail of the fuse into the barrel until the fuse head contacts the upper end of the barrel. Replace the barrel cap and tighten it with your hands until it is snug. It is recommended that you not use pliers or a wrench to tighten the cap. Turn the barrel over and arm the tensioner. Loop the tail of the fuse around the post snugly and then tighten the nut by hand. Then, use a crescent wrench to tighten the nut sufficiently. The final step is to inspect your work thoroughly. Make sure the fuse is properly installed. If all appears to be in order, cut the excess of the fuse tail as close to the nut as is possible. The barrel is now armed and ready to be installed in the cutout. Note: the tail of the fuse should not be wrapped around the post, simply looped over it. Installation of the barrel into the cutout. The bottom of the cutout has two grooves that should be aligned with the guides on the barrel. Hold the barrel in your hand with the cap pointed toward the ground. Place the finger of the hot stick in the upper eye of the barrel and raise it toward the cutout. The guides on the barrel should be aligned with the grooves on the lower portion of the cutout. Place the barrel into the grooves and allow it to hang. To test that the barrel is properly aligned with the cutout, place the finger of the hot stick in the eye of the barrel and swing it 90 degrees 2 or 3 times. If the barrel swings freely, it is properly aligned and ready for closing. If it does not move freely in the grooves, repeat the installation process. Closing the cutout. A lineman should always turn his face away from the cutout during energized operation. While facing away from the cutout, close the barrel with a quick, forceful motion. Finally, inspect the cutout. Then lower the hot stick. Opening the cutout. When possible, remove all load from the line before opening the cutout. An inspection of the cutout should be made to detect abnormalities that might cause an accident. If problems are detected during the inspection, follow the work methods established by your company to correct the situation. The hot stick finger is placed in the eye of the barrel. Look away from the cutout, then with a quick, forceful downward movement, open the barrel. Warning: opening a cutout under high load conditions may create an arc which cannot be extinguished due to the short distance between the contact points of the cutout. If this should occur, close the barrel immediately and de-energize the line at an oil switch before attempting to reopen the cutout. Warning: never open or close a cutout with your hands, even if you believe the line is de-energized. The majority of electrocutions or electric burns happen on lines that are believed to be de-energized. Always use your hot stick. As in any portion of line work, a lineman must use the proper equipment, wear appropriate clothes, and utilize appropriate safety gear. Always inspect the hot stick to make sure it is in good condition. Always maintain a prudent distance from the cutout when opening or closing it. Operating the cutout. Fuses are a fundamental part of coordination in the electrical distribution system. It is critically important that a burned fuse be replaced with a new fuse of the same capacity. Fuse sizing is determined by a coordination study of the line. Fuse capacity should not be changed unless a study indicates that the system coordination will not be adversely affected by the change. If a fuse of a larger capacity is installed in a cutout, it can cause the OCR to open permanently instead of blowing the fuse under fault conditions. This will result in a larger number of consumers without power than if just the fuse had blown. It also complicates fault troubleshooting, which prolongs the outage. Review. Properly install the cutout with an angle towards the pole. Inspect the cutout for damage before operating it. When possible, remove the load from the line before opening or closing a cutout. Always use the hot stick to operate the cutout. Replace blown fuses with new fuses of the same capacity. Always look away from the cutout when opening or closing it. Use the proper safety tools and equipment. In today's electric utility industry, fuses are an integral part of the distribution system. By following the procedures that have been presented in this course, you can maintain or improve the reliability of your electric system, which will provide your customers with more dependable, quality electric service.